Hi folks, Jack Summers here, Smoky Mountain Scientific. I want to talk to you today, give you a little rundown on the project we're working on. It's a chemical kinetics project, and it uses the hardware that we made in our little laboratory shop. This shows a picture of an injection apparatus that has two syringes, one of which has a base solution and one of which has a crystal violet solution. And when you mix these two together, you will get a reaction that quenches bleaches out the spectrum of the crystal violet, and you can measure it spectrophotometrically. All right, so up on the top we have a motor that runs a screw that injects the solutions. Okay, both of the solutions are pushed at the same time. They go through these plastic tubes, and when you have the thing set to run the spectra, you inject both of them into this T-fitting, and from there into this cell. Okay, so this is a UV vis absorbance cell that we made. And it's got some quartz windows in there and O-rings to seal it. It has fiber optic fittings that let light in, let light into the cell and let light out to the spectrometer. The spectrometer we're going to use is this Thor Laboratories CCS 100 spectrometer. It cost us about $2,000. And the apparatus here cost about $1,000 to make. So this is in scientific equipment terms rather inexpensive, and that's what our goal is, to come up with something inexpensive. So that's what the hardware looks like. I've been working on user interface, and this is written in C# using Code Composer Studio free mode. Alright, so this is the main window. You hit the pump. We have three modes. It has a pump mode that allows you just to run the pump. It has a software trigger spectrum mode that allows you just to acquire a spectrum. And it's got a third mode, which is the kinetics experiment, and that's what I'm going to talk about. So first of all, we have to connect the spectrometer. You click on that button, and it takes a little bit of time, but it says connected to the Thor Lab CCS 100 spectrometer. And then you hit the pump button, and we connect to our apparatus on communication port 4. We can change the volume of solution we add. We're going to add 600 microliters from each of the two syringes. We can change the number of scans we got. I guess 10 is probably good enough. We're going to estimate that the experiment will take about 4 seconds to run, and let's give it 25 seconds of total time. Alright, you could have heard in the background there the sound of the valves and the motors turning, and that had the effect of injecting our solutions. Once the solutions are injected, there will be spectra acquired at different data points, and it'll acquire until 25 seconds have elapsed. That says our acquisition is complete. We'll hit the OK button. Now we're going to save the data. Alright, so let's call this JS Data 9. And that's going to save to this path down here, Summers Document Spec Data, JS Data 9. So we hit the Data Save button. It says over here that the data has been saved. And now we can, let's see, JS Data 9, we can find that, double click on it, open it up in Excel. And what we have across the top, we have the time delays in milliseconds. So the first one was acquired without a delay. The last one was acquired at 25 seconds, which is 25,000 milliseconds. We get an estimated background count that's been subtracted from all our other data. So let's get a graph here. First of all, we're going to get rid of that thing that says wavelength. We're going to get rid of this whole row. And now let's take a look at the spectra. So insert chart, scatter plot, and that's what the raw data look like. Okay, once you have the raw data, you can convert it into absorbance. You can do whatever kind of background subtraction you want to do, and that is going to be the subject of another demo on another day. We're working on a user interface for spectral analysis, but that's not part of this talk. All right, thank you for watching, and good day.